I'm going to look at this polynomial fit from lab 3. Some people were having issues with the units, so I'll just sort of run through the whole scenario. I might not label all my axes and stuff. That's usually. So this is the polynomial data from lab 3A. Let me open up one of my Excels, pasting the data in. And this is one of those I need to throw some data away problems. So first I'm going to make a quick plot, highlight the data, insert, make an XY scatter. And I don't want this flat part. It's this parabola I want. I've got the axes in the right order. I want position versus time. So position is on the y-axis and time is on the x. And in Excel, we want the x first. So this is a good order. But there's too much of this flat part of the data that I don't want. I'm only interested in the parabola. So I'm going to go from 0.4756 to 9963. So I'm just going to remake the graph, or I could delete the data either way. So, but I'm going to remake the graph here, just highlighting that data I want, and then do an insert XY scatter. Now there's my parabola part, and there's this one point. Maybe I should, it's maybe throw it away, maybe keep it, who knows, but I'm going to keep it. And what do I want? Quick layout number 9. That's not a good fit. I want a polynomial, so I'm going to format my trend line to a polynomial. And that looks a lot better. I'm going to get rid of my legend. This x-axis was, that's not what I wanted to do. This x-axis was time in seconds. This y-axis was position in meters. It was some projectile data. And maybe I'm going to start it, format the axis. Maybe I'll start the minimum time at 0.4, get it, use more of the space. There we go. I have it fit to a polynomial, which is what I wanted. I'm going to increase the font size of my polynomial so I can see it a little bit better. Okay. So there's my polynomial fit from Excel. And then I'm going to compare that to, I'm comparing that to this formula. Okay, so we know that what's on the x-axis is time. So when you see x squared over here, you think t squared. So you have to make that sort of idea. And over here, the x squared is first, and over there it's last, and that doesn't matter. Okay, so y0 is the term that doesn't have any, that's the constant term, no x's. So in my Excel over here, that number's the 3.2023. And that has the same units as a y, because it says y, all these, I have 3 terms, but this term has to be the same as a y, and so that's meters. The next term I'm going after is the V0, and it's the linear term. It multiplies t, which over here is x, and so that's minus 7.7054. And that number multiplied by an x has to give me a y. So y is meters and x is seconds, And so this number, when multiplied by seconds, should give me meters. That makes it meters per second. If I have meters per second and I multiply them by seconds, those seconds cancel and I'm left with just meters. So I want overall, I want this the number and the x combined to be a y, which is meters. And if x is a second, then this must be meters per second. Now the hardest part is the acceleration. So over here, the acceleration is related to the square term, and that's the 5.1. But it's not simply a by itself, it's 1/2 of a. So 1/2 of a is equal to 5. So let me do my little snip thing. And open a blank page for a second. And so I have that 5.1088. That number from Excel is 1/2 of a. That was from the formula. Over here, the formula, the coefficient of the square term is 1/2 a. And over here, the coefficient of the square term is 5.11. So that's what I have. 5.1088 is equal to 1/2 of a. Multiply both sides by 2. And so the acceleration is about 10.2. So I'm just going to say 10.2. And you can do better than me. And then the units. Okay, so this number multiplied by x squared gives me a y. So I want, when I'm done meters, I'm going to multiply some number by x, which is seconds. I'm going to multiply by seconds squared. So I want something that when I multiply it by seconds squared, I get meters. And that's meters per second squared. I'll just use the caret. So there are two weird things about that last one that you have to multiply by 2. It's not that weird, but you have to multiply by the 2 and the units. So you have to realize that you're multiplying that number by time squared. And then when I'm done all that, I want meters. So it must be meters per second squared. Okay, so that is how to get the A, how to get rid of the data you don't want, fit it to a polynomial, relate it to the polynomial from theory. There's that extra weird little 2 with the acceleration and what the units are. All right, so I'll stop recording there.